Good day, everyone. Our topic for today is all about the basic properties of logarithms. And to start, let us have this definition. Let b and x be real numbers such that b is greater than 0 and b is not equal to 1. The same condition in our exponential form, that b is greater than 0 and not equal to 1. The basic properties of logarithm are the following. First, if you have logarithm of 1 in any base b, it is just equal to 0. Why it is possible? So if you have why it is true. So if you will remember in our previous video, in converting logarithmic to exponential, so the very first thing that we do is we just have to copy whatever number here. So you have the 1, and you get the base b, and whatever is the number here becomes the exponent. So it so this is really true because b to the power of 0, or any number raised to the power of 0, is 1. So again, this log 1 base b will only be true if that is equal to 0. And the same thing for the next property. By the way, before we continue to the next property, so if you have log 1 in any base, say for example log of 1 base 10, so it is automatically equal to 0. Or log of or logarithm of 1 base 25, it is just directly equal to 0. That's the property number 1. The next property, the logarithm of b to the power of x into the same base b. B and this b are the same. If these two are the same number, automatically the answer is your exponent. Why it is possible? Because if you will rewrite this logarithmic form into exponential form, this can be written as, first you copy b to the power of x, whatever is written here, your base b, and this x here becomes your exponent. So they are identical, right? So it means this logarithm of b to the x base b will only be true if this is just equal to x. And for the last property that we will have, it will only hold if your x is greater than 0, or it is a positive number. So if you have b to the power of log of x base b, this base and this number are the same, automatically your answer is your x. Say for example, you have 5 log of, say, x base 5, so automatically whatever is here will be your answer. Okay, let's apply it here in our example. So here, the instruction is we use the basic properties of logarithm to find the value of the following logarithmic expressions. So we will be simplifying all of this using the properties of logarithm. So it's either we will use property number 1, 2, 3, 1, 2, 2, or 3. Let us start with the letter A. In the letter A, we have log of 10. It is obvious that there is no such base written, so it is understood that the base is 10. So as you can see, since we know that this is just a base of 10, so you have imaginary, you have there 10. So they are just the same, so it is obvious that we will use property number 2. But the problem is, what is the exponent? So it is understood that the exponent here is 1. So here, your answer is 1. Just simple as that. So we just use the property number 2. You just get the exponent, and that is now your answer. For the letter B, you have ln of e to the power of 3. So it is a natural logarithm, and we all know that you just write it here properly. That is e to the power of 3, and we know that the base here is the transcendental number e. And the same thing, they are the same, so obviously it can be used here, property number 2. So you just have to get the exponent here, and that will be your answer, so it is just equal to 3. For the letter C, so we have here logarithm of 64 base 4. So we cannot use number 1 here because it is not 1. We cannot use number 3 here because it is not of this form, so obviously we will use number 2. But the problem is we don't have 4 yet here. So we need to rewrite this in a way that the base here will be 4 and it will be equal to the base here. So you have logarithm of, we know that 64 can be written into 4 raised to something, and that is 4 raised to 3, because 4 times 4 is 16, times 4, that is 64. So simply 64 can be written as 4 to the power of 3. Okay, so we already know that 64 is equal to 4 cubed, and we know here that the base is 4 as well. So they are the same. So if you will use property number 2, it is just equal to your base. So your answer is 3. So for the letter D, we have the logarithm of 1 over 125 base of 5. So as you can see here, uh, again, we cannot use number 1 because it is not 1. We cannot use number 3 because it is not of this form. So obviously, we will use property number 2. But again, we need to rewrite this in a way that it will be the same with the 5 here. So it is obvious that this can be written as 1 over, we know that 5 times 5 times 5 is 125. So it will be 5 cubed base 5. And then we can simply transfer this denominator in the numerator, but the exponent now becomes negative. So you have logarithm of 5 to the power of negative 3 base 5. So now they are the same, so we can apply property number 2. So your answer now is your exponent 3. So this is just equal to 3. This is just equal to the negative 3. Okay, let us have the letter E. For the letter E, you have 5 log of 2 base 5. So obviously, in the form that we have, we will be using number 3. But then again, see to it that the x that you have here is greater than 0. And obviously, it is 2 and it is greater than 0. So we can use property number 3. So the 5 and the 5 are the same. So your answer here is 2. So for the letter F, we have log of 1. Nothing is written. It means base 10. Anyway, in any base that you have, based on property number 1, it is always equal to 0. Okay, let us have more examples. Okay, so we will have now this one. Use the properties of logarithm to find the values of the following logarithmic expression. So we will be simplifying this 6 examples. First is you have, oops, we have there, so we need to share it again. So let's continue. Let us have the first one is A log of 7 base 7. So as you can see, it can be, you can apply here property number 2. We know that the exponent here is 1, so your answer is 1. 7 and 7 here. Next, here for letter B, we have e to the power of ln of 5. So obviously, of this form, we will use property number 3. And we know that this is just e to the power of log of 5 base e. Because it's ln, it means understood that the base is e. And they are the same. So your answer here is 5. Again, this x should be greater than 0, and it is 5, and 5 is greater than 0. Letter C, you have log of x squared base 10. So as you can see, no, wait, it is just log of 10 to the power of x squared. So nothing is written here in the base. It is understood that there that the base is 10. So they are the same. So automatically your answer will be this one. So your answer is x squared. Next, for the letter D, you have log of 1 base 3. From property number 1, you have log of 1 in any base. Here, the base is 3. Automatically, that is equal to 0. Okay, let us have letter E. So we have ln of e to the power of x plus 1. Again, the ln is just a logarithm of base e, so somehow it can be written as log of e to the power of x plus 1 base e. And then again, they're the same, so your answer is your exponent, so that is just x plus 1. And lastly, for the last example that we have logarithm of 1 over 49 base of 7. And then again, you cannot use property number 1, you cannot use property number 3 either, so it's very clear that we will be using property number 2. So we need to rewrite this in a way that it will be the same with the 7. So we know that the 49 can be written as 7 squared, and then base 7. Then again, you can transfer this 7 squared above, but then this time your exponent becomes negative. So you have logarithm of 7 to the negative 2, base 7. So the 7 now are the same, so your answer is negative 2. That is all for today. Thank you for watching the video, and see you for the next one.